If you haven't already gotten a calculator, grab a calculator. You can use a graphing calculator. Today's notes are going to be pretty short. So on the notes, we're doing, there's a day 2 and a day 3. We're going to do day 3, and then we're going to do day 2 next time. So make sure you're on the side that says day 3, because there's a side that says day 2. We're not on day 2. We're going to do day 3. Please put your phones away, your earbuds away, your headphones away, Chromebooks away. We're going to take notes. Please put your Chromebook away. We're taking notes. Do you even have the notes?
No, but all my stuff in my backpack. So. And
So make sure you get the notes. They're on the front table. Did you already pick them up for today? Please get them. So this is day 3. Like I said, there's a day 2 and a day 3. Make sure that you're on the side that says day 3. So synthetic division can only be used when the divisor is linear. What that means, linear, is that this part right here, the x plus or minus, and the divisor is what you're dividing by. So divisor is what you divide by. So the thing that you're dividing by is like here, it's that stuff divided by this stuff divided by this. So it has to be like an x plus or minus something. That's what it's saying. It's just x plus or minus a number. A is just a number. So it has to be to the first power. That's what it's saying, that here it has to be to the first power. So everything on the backside, it is to the first power. And so to do synthetic division, next class, we're going to do long division. Do y'all remember doing long division in, like, I don't know, 3rd grade? That was fun, right? Okay, synthetic division is much faster. We're doing it first. Synthetic division is faster. But here's something that we need to know. You have to make sure you have a placeholder for everything. That means that when you're looking at what you're dividing, this part, it has to look like this. Like that one is to the 3rd power. It has to be something to the 3rd power plus something to the 2nd power plus something to the 1st power plus a constant. It has to have all those placeholders. And so if we look, this goes from an exponent of 3 to an exponent of 1. So do you guys see that we're missing the x squared term? So we're going to fill in the placeholders with zeros. So we're going to have to say missing right here is plus 0x squared. So we fill it in with zeros. So we've got 3, I'm looking at the exponents, 3, 2, and then that's a 1. We're missing a constant. So at the very end, I also need plus 0. Thank you. I'm going to go ahead and look at B because I'm going to set both A and B up at the same time for what we're going to do. It's written backwards, but I have something to the 3rd, to the 2nd, to the 1st, and then a constant. So I have everything for B. It's good. It's already set up. It's just written backwards. We're going to rewrite it, but I have all of the terms. The first thing that I have to do once I've decided that all my terms are there is I have to look at what I'm dividing by. So remember last class when we talked about factors, and if you have a factor, you can figure out what x equals because you could set it to 0. And when it looks like this, it's easy because if I set that equal to 0 and I subtract 3, then that means this tells me that x is equal to -3. And for what I'm dividing by on this one, if this is x minus 1, well, then what does x equal? 1. That x equals part is going to go like in a house. So it's going to go over here in a little house. And then for this problem, it's going to be a 1. So you always start with what x equals. And then all I'm going to do is only write the numbers. So I'm going to write that off to the side so that you can have a little bit of notes. Only the numbers. Those are called the coefficients. So what that means is I'm going to go here and only write the numbers. So I have a 3, a 0, a -27, and then a 0. So I'm just going to write them with a small little space in between, only the numbers. Not a 3, or not a 0, it's a 3. 3, 0, -27, and then 0. I'm going to do the same thing over here, but this one I'm going to write backwards because it needs to be written with the biggest exponent first. So I have a -1, 2, -3, and then 5. Everybody with me so far? Like maybe you don't understand it yet. We haven't really done any examples, but this is where the numbers come from. The next thing that I'm going to do, because these are going to be kind of like addition problems. Is that you put a line and you draw an arrow. When you draw that arrow, what it means is that when you start the problem, first thing you're going to do is drop it like it's hot. That first number drops down and that's part of your answer. So for the first problem, A, you bring it down and there becomes a 3. You drop it down. From there, everything else I'm going to figure out by whatever number came below the bar. I'm going to take that and I'm going to multiply it by the number in the house. And then I'm going to rewrite it and then I'm going to add. And so I'm going to talk you through it. So it might be easier if you just watch me and then you can write it down. So the first thing I did was drop it like it's hot and I got a 3. So I will do 3 times -3. What's that? Now I add 0 minus 9 is -9. Now I'll multiply again. So you multiply, add, multiply, add. So -9 times -3 is positive 27. So 27 minus 27, that's 0. What's 0 times -3? 0. So again, these are the numbers that I figured out. The blue part is what I set up. So I'll talk you through it again. I first drop it like it's hot. Then I multiply. 3 times -3 gave me -9. 0 minus 9 is -9. So you add this way and you multiply that way. So -9 times -3 gives me positive 27. -27 plus 27 gives me 0. Anything times 0 is 0. 0 plus 0 is 0. So I'm done so far. Let's go do the other one. So let's do part B. So everything so far is just setting up the problem. So now I'm going to work it. So to work it, -1 times 1 is -1. Now I add 2 minus 1 is 1. 1 times 1 is 1. -3 plus 1 is -2. -2 times 1 is -2. 5 minus 2 is 3. So again, you start with the number at the bottom, and then you multiply, add, multiply, add, multiply, add. My answer. First of all, you can tell me if it's a factor or not, because the very last thing is your remainder. If something divides evenly, do you have a remainder? Do you have anything left over? No, so the remainder is what? 0. So if something is a factor, then it divides evenly. So one of these is a factor. Which one is the factor? Or which one? This one. It's a remainder of 0. So that means, is x plus 3 a factor? Yes. So for this one, is a remainder of 3, would that be a factor? No. And for this one way that you can know, yes, it's a factor because r is equal to 0. No, it's not a factor because r is equal to 3. The remainder has to be equal to 0 for it to be a factor. My result, to be able to write your result, we're going to write these, but we're going to start, you have your remainder, and then you start with the 1 over. So this is going to be my constant. This is going to be my x. This is going to be my x squared term. And when you do this, you'll always be 1 less degree. So you started out with a degree of 3 or an exponent of 3. When you end, you're going to be 1 less. So it's an x squared. So now I'm going to write my answer. My result looks like this. 3x squared minus 9x. Do you have to write plus 0? No. So that is my answer. My other one, I'm going to label it. So you start with a remainder, then you always have a constant, and then an x, and then an x squared term. And again, it's x squared because I started with something to the 3rd power, so now it's to the 2nd power. So when I go to write my answer, and don't write the remainder because the remainder, I'll show you how to write it. So we get -1x squared. I don't have to write the 1, but if I write it, I'm not wrong. Plus 1x. I don't have to write the 1, but if I write it, I'm not wrong. Minus 2, and don't write the c. The c is just saying it's a constant. A constant is just a number. For the remainder, you will always do plus the remainder divided by whatever it is you were dividing by. So this case, I was dividing by x minus 1. You divide by x minus 1. So the remainder is always plus your remainder divided by your divisor. So if your remainder is 0, you can stop. That is synthetic division. And sometimes we have problems and they're written like this and they just want you to divide. Sometimes we have problems and they are written a little bit different, but we're still going to do synthetic division. So, oh, I forgot I have a brain break. Bless you.
My name is Lisa, and addiction cost me the son. No matter what he told me.
Name something you'd hate to discover hit you while you were sleeping. Bit you.
Sorry, but
We can try it. I don't know how to spell that.
snake.
How do you spell scorpion?
SCO.
Like that? Hmm. Yeah, I would really hate to get bit by a bat. I definitely would. But that's not what came to mind. All right, the remainder theorem. So if we're dividing f of x by a linear term, so that's kind of what we just did. The remainder is f of a. So we're going to do the first two problems one way, and we're going to do the bottom two problems a different way because you can do them either way and it works. So this says f of 1. That means x is equal to 1. This one, x is equal to 4. So we don't change it. It's not opposite because it's not giving us a factor. It's telling us f of x. So don't change these. But I'm going to set up synthetic division. When I set up synthetic division for these, I'm using the same polynomial for everything. But as I look at it, it looks like it goes 5, 3, and then 2. I'm missing quite a bit of terms. So I have to make sure that I add in right here has to go plus 0x to the 4th. And then at the end, I have to have plus 0. Oh, no, not just plus 0. I can actually write it at the end. I have space. Plus 0x and then plus 0. So I have to make sure that I have all of the terms. It goes 5, 4, 3, 2, 1, and then none. So I have to have all the terms there. Now, when I set up synthetic division, I only write the numbers. So it looks like the numbers I have are 1, 0, -13, -12, 0, and then 0. So it's quite a lot. So leave yourself enough space. And I can set up my next problem too. It's the same exact numbers. I have a 1 and then a 0. So remember that we'll set it up and then we have to first drop it like it's hot for both of them. And for these problems, when we do them, it only cares about the very last value. It only wants to know if it's a factor or not. That's it. So remember that you can have a zero, a root, an x-intercept. Those all mean the same thing. A factor, those are all the same thing. So I'm going to start here. You drop it like it's hot. So you start with 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 13 plus 1 is negative 12. Negative 12 times 1 is negative 12. Negative 12 minus 12, what's that? Very good. Then I have 1 times 24, negative 24. So this is negative 24. 0 minus 24 is negative 24. Negative 24 times 1 is negative 24. 0 minus 24 is negative 24. The very last value is the only thing that I care about. That is my remainder. So does that remainder of negative 24, does that mean this is a 0 or a factor or a root or an x-intercept? No. So we can say no, because the remainder is equal to negative 24. Let's do this next one. So we start, no, it won't be the same because this is a 4 now instead of a 1. So we drop down the 1. 1 times 4 is 4. So now we have 0 plus 4. Now 4 times 4 is 16. So if I have negative 13 plus 16, positive 3. So now we have 3 times 4 is 12. Negative 12 plus 12 is 0. What's anything times 0? 0. So I get 0. 0 plus 0 is 0. 0 times 4 is 0. 0 plus 0 is 0. So for this one, my remainder is 0. So is x equals 4? Is that a root? Yes. Why? Because r is equal to 0. So the remainder has to be equal to 0. Give me another word for street.
Parkway. Me. Drive block.
Street.
Yeah, way.
Good one.
Oh, that's.
What?
That one's so obvious.
If I were only there.
No longer? What?
Ah, pretty.
Popular. Yeah. Okay, these are gonna be dumb, aren't they? These are not the easiest thing you've done. They're gonna be dumb.
Oh my goodness. Oh, I forgot to do the fast money round. Let's just play again then.
And we did so badly that they just didn't allow us. man.
Name a gift you would buy for a dog.
Bone. Tree. Tree. Bed. Bowl.
Okay.
Goodness. A ball? Another dog? A ball. Another dog.
I feel like I've had this one before. A bone.
It is to some of the owners. Some of the owners not to go.
Frisbee.
That's why you can use it.
I think that's toy. I think I remember thinking the same thing last time, that like, why is a rawhide not a bone? But I guess they are different. Besides photographs, name something specific that gets framed.
Living things. So. No, very good person. Thanks.
Besides regular Sunday, tell me an occasion when someone might go to church. I think it's saying besides a, well, okay.
Confess my sins. What? Oh, yeah.
Name a perfect strangers, name a place perfect strangers sit next to each other. Name something grown-ups sleep with in order to feel secure. Name a specific form of entertainment you think costs too much. Name a place where you always seem to get in the slowest line. Tell me something that describes that's described as prime. Meet.
How is that not?
So let's see, y'all should come first. Second. So we have two more problems that we're gonna go to do together. So we're still working on the same exact problem. We're still doing the same exact problem. So for C, x equals 0. So when I set it up, it's 0. For D, x equals -2. So I set it up with -2. And then I write down what I have. So it's the same numbers. So it's 1, 0, -13, -12, 0, and then 0. I'm going to set up the next problem so it's ready to go. So they're ready to go. All we've got to do is start evaluating. They're the bottom two. You're using the same problem. Like all four of these are the same problem. It's A, B, C, D, but you're using the same polynomial. So for this one, drop it like it's hot. So you start with 1. 1 times 0 is 0. 0 plus 0 is 0. 0 times 0 is 0. No. So 0 minus 13 is -13. But -13 times 0 is 0. So then you get -12. -12 times 0 is 0. And then you end up with zeros. So is 0 an x-intercept? Yes. Yes. And it's because the remainder is 0. Hello? No, because I don't have rosters. No. Mm-mm. All right, thank you. Unless somebody wants to come show me how. All right, so I've got one. So the next one, I'm going to do it up on the board. I want y'all to do it on your paper and let's see if we get the same thing. Did y'all get the same thing? Beautiful. We're done. That's all we're doing today.